Hello and welcome. So we have given the links to the circle below, solve for x. So let's look at what we're given here and what we know from what we're given. So first off, first thing that grabs my attention is this little right angle here. So we have the center of the circle, and from that we have a line coming straight out and intersecting this chord. Chord meaning just a line within a circle, right? That yellow line is a chord. Okay, so we have the pink line intersecting the yellow line at a 90-degree angle. Now, why does this matter? Well, circles have a special property where when it intersects that line at a right angle, that means that we have this cool property where that line will bisect the chord. That means that that distance on either side is going to be the same. So this point right here is hitting directly in the middle of that line. So that means that if this is some distance d, that means this is that same distance on the other line. Right? So that means now we know this distance is some distance d, right? And that's the same distance, and the whole thing together is x. Huzzah! Okay, we're also told 2.6, right? We're told that little distance of the line there. And we're also told that this distance here is 10. Now what's cool about this distance is that this distance of 10 is the radius, because you'll notice it goes from the center of the circle to the outside. That means that anywhere you draw a radius, it's going to have a distance of 10. Right? If you wanted to maybe extend that line, you could, and that whole distance would be 10. Now, the reason why we have to know and identify that as a radius is, what if we draw a radius from the center to, say, J right here? Oh, I draw like an awkward parabola. There we go. That means that distance there is also 10, right? And the reason why we draw it that way is that now we've made something very, very helpful called a right triangle. Wow! Right? And right triangles are supremely useful because then, with any right triangle, you now have the Pythagorean theorem in your arsenal, right? Remember, Pythagorean theorem is that if you have some leg, A and B on a triangle, right? Legs A and B and hypotenuse C. Then the Pythagorean theorem says that you take your legs squared, the sum of your legs squared equals your hypotenuse squared. Booyah, right? So we have one leg here that's 2.6. So 2.6 squared plus your other leg, D, squared, equals your hypotenuse, 10, squared. And now you have an equation, you have a relationship set up, use it, right? So at this point, then that would be 2.6 squared, so 2.6 times 2.6, which is 6.76, plus d squared equals 10 squared, which is 100. Okay, and from there it's just solving for d squared, right? You want to get that alone, so we're going to move the 6.76 onto the other side, right? It's positive, so we're going to move that with subtraction. So subtract 6.76 to both sides. Okay, so those will cancel, and we're left with d squared equals, that would be 93.24. Yes, 93.24, confirmed, all right? So then you're looking at that, and that is your value of d squared. Now, your goal is to solve for d, not d squared, right? Which means that we need to get rid of the square. How do we undo a square? Well, with a square root. Remember, as soon as you take a square root, then what's going to happen is that you have a plus and minus, right? But that's actually not going to make a difference here, because remember, d is an actual length. And can lengths be negative? Right? If you're looking from wherever you're at to the other side of the room, is that some negative distance? No. No, distance is always positive, which means you'll have a positive square root. And then you'll have the square root of 93.24 as your distance d. Alright, so what I would do, turn to my lovely handy calculator and say, alright, square root 93.24, and we get a value back. 9.65608, so on and so forth. Okay, now are we done? Is this our answer? No. Remember, what was your goal? It was to solve for x. And is d x? No. D was half of x, right? Because d plus d, both of them together, will be your x. So all we have to do is we say, okay, well, we only have this distance to get the rest of the way. That's just another d. So all we have to do is just take our number that we found for d, right? And then multiply that by 2. And that means that the entire chord length will be 19.3121723, so on and so forth. Now it says round to the third decimal place, so we're looking at 19.312. Because the 1 after the 2 rounds down, so it'll be 19.31. So 19.312. Bam. Okay, and that's it. That's as crazy as it gets. You're done. It's been solved. Thanks for watching.